This video introduces a TRINITY module remote control for industrial robot with the developer version of Showcase, create GUI in Node-RED, and control physical robot. In this video, we will briefly explain the system requirements and the structure, and then I will explain the demo system. And next, I will show you to install the Node-RED and the dependencies. And next, I will show you to create a simple Node-RED GUI. And last, I will show you to control the physical robot by the GUI. The main OPC UA server is running on the server PC, which is running in Windows 10 system. And the physical robot system will move and feedback joint parameters to OPC UA server. The simulation software Visual Components Premium 4.3 is running in this server PC, and it's connected with the OPC UA server. The digital twin in Visual Components will move according to the joint parameters in OPC UA server. The client PC can start UA Expert to access the OPC UA server to view or change the server variables, and the GUI in Google Chrome browser can also view or change robot joint variables. In addition, mobile phone can also access to the same GUI. In this short video, we cannot show you to build a complete GUI like we made for our lab, but we can show you to build the simplified GUI. The GUI required Node-RED installed in the Ubuntu virtual machine, and the virtual machine running under the Windows host machine. Then we can use the Google Chrome browser in the host machine to edit and programming the Node-RED, and we need to run OPC UA server and the Visual Components in the host machine so we can test the GUI in the simulation environment without interrupt the physical machine. Here I will show you to install the Node-RED and its dependencies. Basically, we will follow the steps in this link to install the Node-RED. First, to prepare the system by input the following command. After the installation finished, then we can install the Node-RED by input the following command. You can choose all yes during all the installation. When you see something like this, it shows all done. Then we can say the Node-RED installation is finished. Then we can open a browser and open another terminal. In the terminal, we can input Node-RED start to start the Node-RED. And then in the browser, we can input the localhost or the 127.0.0.1 and 1880 to open the Node-RED. And then the Node-RED programming interface is showing in the browser. Then now we can say the Node-RED installation is succeed. Now we should continue install the OPC UA library for the Node-RED. You can install it by input the following command in a new terminal. After the installation finished, you need to restart the Node-RED to view the OPC UA functions. You can restart the Node-RED by input Node-RED stop and input Node-RED start and refresh the browser. In the left side of the Node-RED programming interface, scroll down to see the OPC UA functions. You can drag it out by mouse. Now you can say the OPC UA library installation is succeed. Now we should continue install the dashboard library for Node-RED. You can install it by input the following command. Same as OPC UA installation, you also need to restart the Node-RED and refresh the browser to see the changes. Scroll down the left side to the bottom and drag out some dashboard function nodes to verify it. Now we can say the dashboard library installation is succeed and all the dependencies installation is done. We can start to program in the Node-RED. Okay, we can start to program the Node-RED. Here I will show you to program the simple GUI for controlling the two variables in the OPC UA server. We have created a server in previous videos, and the server has 6 variables, but in this demo GUI I will only control these first 2, which is ns2 and id is 3, ns2 id is 4. And okay, then we can start. First I need to drag this inject here, and I also need to drag out this function here in this GUI interface, and in the double click open, and also here, and to check the inject once after 0.1 seconds. Then we check done, and also in the function I will name it as init. It's a initialization function here, so it will only execute once when you load the GUI here. And this is the code, and the topic will be the Office UA topic. This is the value for this one, ns2 I equal to 3, and the data type is double. And this is the second topic. For the second value is ns equal to 2, and the id is the 4, also the double value. So this is save the topic value, and save the value to the flow. Also save this A2 topic and save the value to the flow. And also the A1 minimal value is -170, save it to the flow, and also A1 max value is 170, and also A2 minimum, A2 max, or save it to the flow. Then we check the done to save it in the interface. So now you open it, it will remember. Then now we can drag out another one, and also name it read A1. So in this read A1, I will check this as a flow and write A1 topic here, and inject once after 0.1 seconds, and we check down. So it will read remembered the A1 topic that is here, this A1 topic, and this will send the value to the following position here, and the following here will be the Office UA client here. That is this. I connect here, and the client I will make it as subscribe, and we name it to subscribe UA. Yeah, and make it interval is 1 millisecond, and finally we should check the endpoint. So no endpoint here, we should add one, and the endpoint will be from this here. I will copy this endpoint position and paste it to here. Then the security is none, then we just click add, then also done. So then we will subscribe the A1 topic by this method, and also we need to visualize it, and that is will be using the dashboard function from this gauge. Drag out here, we connect here, and in this gauge I will name it to A1 because it's to visualize the A1 value, and the range should be -170 to positive 170, and also I need a group, click here. I need a tab for the group, click here. Just if you have a name for this, you can name it here, but I just keep it default as home. Add, and the default name for the group will be default. Add, and nothing to change here. It's done. Okay, then we can open a new window, because now we are in the programming interface for the Node-RED. we can go to the UI interface. Now I copy this same code, same position here. Use UI here. Enter. It will go to the Node-RED dashboard, but now it's nothing here until we check the deploy. Then it's deployed. Then it will become a gauge in here. But the value have no meaning. Maybe no meaning. It's only a gauge. I need to have a way to set it. It cannot to add or decrease. So then I also need to finish this gauge. I need a function here. Drag it here. And this function is used for update value. And it has only one line to add here. That is this to add the save this A1 type tempo to the flow, and we check down. Okay, so then I will add two buttons here to set the value increase and decrease. Two buttons here, and the first one I make it as a name A1 plus, and I will make the topic. I don't need the topic in this place, and the payload I will set it to plus. It's a string, and okay, for done. This is A1 minus. I don't need the topic. I make it string and remove this, and the payload will be plus. Yeah, and oh, this is minus. Payload will be minus because it's minus. Then I will make another function here, and the function will be to organize the logic of the plus minus button, and I will name it as A1 right, and I copy my code from my previous program is here. Yeah, so you can directly read in the video and type it in your code, in your place. But you can first to read it. So first I will get this topic and get the minimum maximum range for the joint, and also get the current temp. And this is the logic. I don't need to explain this detail. I just show you here. You can type it in your program. Okay, and check done. And after this, I will add one more client here. Client will be right, and the same endpoint, and it's called right. It's only a name. You can name it as you want, and then I connect here. Okay, then I will try to deploy it to see what happens. Now there are two buttons here. I click here. It's changing. I click here. Okay, then it's changing correctly. Then I also want to make a second button can be controlled. Just copy the first one, all the nodes, and I paste it here. Then I need to change all the A1 to the A2, and with A1 to A2, the topic will be from A1 to A2. Done. Then here, nothing to change, and the name for the gauge A1 to 2, and I remember the minus 45. Yeah, let me check it in it. So the A2's minimum is minus 45. Yeah, the maximum is 170. Same. So the A2 minimum is minus 45. That is correct. And the update value here, A1 temp to A2 temp. A1 plus should be A2 plus. then nothing to change. This A1 minus to A2 minus, and A1 right here, A2 right here, A2 top, A2 min, A2 max, A2 temp. Okay, this A2 temp. Okay, then I think everything is okay. Then done. And the right obviously is same. Then let me double check. Okay, then I think everything is correct now. Then we check the deploy. Then okay, then this is to gauge. This is to increase A1 and A2. Oh, this increase A2, but this is not so easy to understand for a user. That I need to change the position. Now I cannot change the position. I need to change the position in this place. We go to here in the dashboard, and we move the mouse to here. They have a layout button here. We check layout. Then you see this is the place to change the layout. And I will do this. Follow my step. You can as you want. I will make it smaller. This is for A1. Put it in the middle. Make this smaller. This is A2. And this is A1 plus, but this is not so easy to put. Add one line here. This is A1 plus, A2 plus, A1 minus, A2 minus. Then let's check what is happening for now and deploy. Now it will look like this. Okay. Yeah, then we say here. You see this is -3 and plus 92. And we check here. It is 100. And I think now the UI design is okay now. And for the Ubuntu system in default, the port 1880 is blocked by itself. So if you open a browser in the Windows system, and if you want to input the IP address to access this GUI in this internal virtual machine, you cannot access it here, because now we are just using the internal IP address. First I need to find the external address. If configure. So the address is 10.0.0.1.8. So I can try it here. 10.0.0.1.8 UI. Here is cannot open because the port in default is not enabled. So we should enable the port by input this sudo ufw below 180. Oh, we add this port, make it enabled. Then when that is refreshed automatically. So we can open this same GUI as this one in the virtual machine, and this is the browser in the Windows host machine. It will be the same value. If you change this, also the value will change. And also in this UI expert, you can also see the same value is changed, and here is changed. Okay, now I think now you can use Windows external Windows machine to control the Office UA server, and even if you have mobile phone, and the mobile phone is connecting to the same network, and open the browser on your mobile phone, you can also log into the same GUI. And if you have more programming background, you can add more function to the GUI, so the GUI can be more useful. Here is the demonstration to control the physical robot by the Node-RED GUI. A web camera pointing to the industrial robot, so you can see the physical robot movement in the upper right corner. And a digital twin is running at the lower right corner to show the real-time movement of the physical robot. In the upper left corner, the UA expert is showing the OPCUA server variables. Then in the lower left corner, a browser login to the Node-RED GUI, and we can control the robot TCP position in this GUI. In this demonstration, I changed the robot TCP position several times, and the robot is moving to the target positions. For the safety concern, we limited the robot speed to a very low speed, so all the robot movement is very slow. If you are interested in more tutorials on this module or other use cases, please follow the links in description. Thank you for watching this Trinity video.